Hello, welcome back. Oh, it's so good to see you. So we were doing a U function here, blueprint pure. And it is pure, but it is named get, which is quite boring. Very boring. Boo, boring, lame. So I want to rename it. So it's something a little bit more instructive in blueprints, but I want to keep the name in C++ because I like the C++ name. So what I'm going to do is I'm going to rename it just for blueprints. And we do that with meta. And then hold on, let me just look it up. It's oh godly display name. That's it. Whoops. Display name equals, and you can do quotes if you want. You don't have to, but I'll do quotes. I'll do get race game instance. Called that. So this will override the display name in blueprints, meaning that in blueprints this function will be named something else. Yeah. So now, if I hop into Poopa Shell, I can search for get race game instance, and there it is. How nice. So now we have a function get race game instance, even though the actual function in C++ is called get. Nice. We can also do some more things, like this category here is quite boring. It's a class race game instance. It's like kind of a boring category. What if we want to have a category for all of our race game related functions? So then we can put a category on it. We can do category is equal to like race, and then subcategory game instance. We'll do something like that. So the categories are separated in with this bar here. So now we can see the category of get race game instance is race and then game instance. So, and that was where the category and the subcategory that I specified. And you can have as many of these subcategories as you want.
That's awesome.
It's quite neat. It's quite neat.
And you get a subcategory with one of the bars.
Sorry?
Like a bar, the bar sign. That for subcategories.
Oh, like if you want to have that actual character in the subcategory, do you mean that?
Yeah, is it like a race? I mean, if I write category and then quotation marks, then I write race and then bar for the subcategory and game instance.
Yeah.
Yeah, okay.
And another thing that would be nice to get rid of, like if I do get game instance, right? You can see there's no world context pin here. Even though this is gameplay static, so let's go look at it. There it is. So you can clearly see it does have a world context object, and we do as well, because that's needed, you know. It's also made a const, maybe I should do that as well. However, their node does not have that as an input pin, while for us, we have this world context pin that we have to fill, which is quite boring. So you kind of saw it in the declaration actually here. You can put meta, world context equals, and then the parameter name. And for objects that can provide a default world context, an actor is one of them. So actor will detect when you're calling a function and it has some world context. It will sort of plug itself in automatically, so it will be hidden. But under the hood, it will send itself in as the world context. So some actors can do that, or actors can do that, and some other U objects can sort of provide an automatic world context if there is one. And to define that, you have to put this world context equals in the meta. So we'll do that as well. So meta equals display name, and then also world context is equal to. Well, ours is just called world context, but it doesn't matter. Just the name of the parameter that is the world context. I'll make this a little bit bigger. So now we can see we don't need to provide a world context because the actor will plug itself in there automatically. So that's quite nice. So now we have a function in Blueprint to get the race game instance. So if you want to get the cars, well, it's not a Blueprint visible. It's not a Blueprint visible node, but actually, let's make it one. So I want to make this cars visible in Blueprint, and you do that with Blueprint. Let's do read only here. We don't want blueprints to actually be able to change cars, but we can say like, oh yeah, you can totally like read the cars array if you want to. So I'll make it blueprint read only. And a default, of course, between like something like blueprint read only and something like edit anywhere. Because these two seem kind of similar. The difference is that edit anywhere means that we can set it as a default value. We can change it in the properties window. So like in class defaults forever, for example, sorry. So this will be something like edit anywhere. We could change it in the instance or in the class defaults. While blueprint read only means that we can access it like a node in blueprint code. So that's the difference between something like blueprint read only and edit anywhere. They control access in two different points.
So edit anywhere will not give us permission to change it in the blueprint.
No, in the blueprint code, no. All right. So I'll just make I won't make it edit anywhere. We don't want to be able to put cars in it or anything, but we do want to make it so blueprint can read the cars if they want to. Right. So now in Poopa Shell, for example, we can do get race game instance, and then from there we should be able to get cars. Yes, there it is. So now we can read the cars property from the race game instance. And then here we can get. We haven't really talked about how arrays work in Blueprint, but they're quite simple. It's the same functions as in C++, really. It's just that you have to call them like nodes instead. That's what this little icon is as well. This like little grid. That means it's this variable, this cars node, is an array. Array of something. We can get, we can set. This is a weird node. We can.
How do we get that target node?
I use drag out from return value here. I use drag out from the race game instance. Use drag out and then type cars. Just get cars. Of course, it has to be blueprint read only or blueprint read write for it to be accessible here. Oh god.
What did you write to get the target cars here in the like in the blue pin?
And dragged out from the return value, typed get cars.
Okay.
It doesn't work. When I drag it out, it just becomes like a disconnected node.
What?
And when I try to drag return, like the return value of get game instance into the insert of that array thing, it says game instance object reference is not compatible with race game instance object reference.
Yeah, you can't drag like this, no. Is that what you mean?
I think.
Yeah, you have to actually get the array first. You have to actually get cars first. And then from the cars array, then you can plug that into get.
I think I know what the problem was. I forgot to recompile the code.
Yeah.
Doesn't quite work, I think.
Show me.
Probably something not catastrophic, I think. Right.
Yeah, you're using get game instance. You have to use the get race car game instance.
Oh. Get race? Oh.
Yeah.
Okay, I see.
So you're getting the base class of the game instance. And here you should have get car, right? Yeah.
There we go. Okay, nice.
Yeah, cool. Coolio. Yeah, it helps to check this context sensitive. Because of course, if I uncheck this, then it doesn't matter what the actual object I'm dragging out from. I can always type get cars. It's just that these two aren't related. Like this game instance doesn't have a car variable. It's just since I didn't have context sensitive checked, it just gets any node from anywhere. And it just happened that, yeah, okay, get cars is the only node that kind of fits that name, even though it has nothing to do with like the game instance object. Like there is no variable called cars in game instance. So yeah, checking this context sensitive can really help you kind of debug what's going on.
Which kind of node do you have after the cars array? It just says get on it, but I don't know what kind of node that is.
So this is the gets an element from an array. So this will be the same as typing like...
Oh, it's like those angle brackets.
So it will be like this. This is the same.
Yeah, but I don't know how I get that though to show up.
You just drag out from the array here, you just get, and then get a copy. Drag out from the array, the cars array here, and just get a copy.
Yeah.
And of course you have stuff like remove, like remove index will remove some index from the array, and you have like remove item. So that would be remove a particular item from the array, and so on. So there's all of the usual array functions here. So I think this might be a good time to talk about. Oh yeah, let's update the code first, right? I'm just gonna close everything. There's so much shit open. So let's use update. Let's see, update start line, so that we actually get the instance. So here, so we use the new function that we made. So this works. We could keep this, but I'm just gonna use the new function that we made. So I'll do race game instance get. I'll do the same with camera. There we go. Very nice.
Wait, how did you? Could you show the get function again?
Yep.
Or that? Yes.
Oh right. Sorry, I need to provide a work context. Whoops.
Oh yeah, that's what was confusing me. Okay,
Yeah.
good.
You were right. So I need to, of course, provide this here. Again, it doesn't matter what the world context is. As long as it's any UU object that lives in some world, then it's fine. So this is usually what you provide as a world context. As long as you're calling it in a U object, like an actor or something, and providing this works just fine. That's my bad. So yeah, nothing should have changed now. We should just use the new function instead of using the get world, get game instance, and yada yada. Okay. So, right. I want to talk about level blueprints, because that's something that you guys are gonna have to interact with at some point when you're making like actual games. So let's do that now. So there's a thing called level blueprints, and what that is that it's a blueprint. So that's blueprint that's in the code that's tied to a particular level. So let's say here's our level, here's our test map. So if I want to go to the blueprint of test map, I click on blueprints up here, and then open level blueprints. Did I do stuff here? Okay, let's just pretend that wasn't there. So this is the blueprint for the map test map. So instead of the begin, play, and tick and stuff being when an actor spawns, so like an actor like I place in the world and begin, play, and tick is running on that. Instead, this begin, play, and tick is running when the level starts. So when the level is loaded and starts, then begin, play is run on in the level blueprint, and then tick is run, every frame the level is currently in the game, currently running.
How did you get to this blueprint?
These blueprints. So
Yeah.
I'm in the editor, right? So blueprints and then open level blueprints.
Okay.
So this is code that's always running when the level is running. So this place is for map specific stuff. It heavily depends on what kind of game you're making, depending like how much code will be in the level BP level blueprint versus how much will be in actors. For example, in It Takes Two, for example, level blueprints will be stuff like triggers. A trigger is usually very often coded in level blueprints, so you'd place out the trigger, right? So let's just do that. Let's do trigger, box trigger. A trigger is just it's just a box component, like as you can see here, it's just a box component. So there's nothing really different from this to just adding a box. It's just that it has some nice callbacks and stuff like that we can use. So I can place a trigger here, for example. God damn it. Like that. So I'll place a trigger. And the nice thing about the level blueprint is that you can directly reference actors that you have placed in the level. So I can reference this trigger actor that I placed down. And the way I do that is just to select it. So I'm selecting the trigger. And just hop into the level blueprint and just hold R, and then just click. And so now I have a reference to that particular actor that exists in the level. It's quite nice.
Oh, that's cool.
So this is where you would do, level specific stuff. So let's say, okay, you can also do, so when you have the trigger when you have the trigger boss, I said it wrong again. When you have the trigger box selected, you can create events for it. So I can right click, and now you can see like add event for trigger box 1. So I can click that. And then I have a bunch of events that I can bind from this actor. So I can say add on actor begin overlap, for example. So this will run whenever trigger box overlaps something else. So I can say like, okay, overlap actor, if that is so I'll cast that to a race car. So it's just a cast. So I'm casting whatever object comes in here, casting it to a race car. If it fails, then I don't do anything. But if it does succeed, I will destroy it. So I'll destroy actor. A simple way of just checking, okay, if the thing that overlapped the trigger box was a race car, then I'll destroy it. So now if we run and drive into it, then nothing happens. So that's great. Does it work? Let's print. Oh, sorry, overlap actor. Whoops, I dragged the wrong pin in. Overlap actor is, of course, which actor triggered the overlap. Other actor is the actor that actually went into the trigger. So that was the wrong object I dragged in.
Wait, how did you get the reference to the on actor begin overlap event?
I selected it in the level. Then I can use right click, then add event, collision, and here are a bunch of collision events that I can bind to. I can also use right click and search like begin overlap. And then that will add an event for that particular actor. So you might imagine I have like 5 different trigger boxes. So I can add an on actor begin overlap for each of those actors. So now, let's see. Boop. And I'm gone. So now we can make like level hazards or something like that. So you might wonder, why don't we just make like a kill actor? Like make an actor that's like a kill box. So you just put this code inside of that actor, instead of making a level actor and then I have to remember to go in and hook that up and stuff. And that is a fair question. And something simple like this, of course, I probably wouldn't do in the level blueprint. I would just make a new actor that has a box component that just like when it overlaps the car, you just destroy the car. Just make that as its own actor. This was just to show you like kind of what the tools in the level blueprint are. And this is unique for level blueprints, I will say. You cannot reference directly actors in the level like this in actor blueprints. You have to kind of get them in somehow by making a U property or something, like we did with the camera, for example. It's just kind of nice in the level blueprint. You can just reference actors directly in the level like this and just add events to this. So this is something that's unique to level blueprints. And it's just to make stuff like this, like trigger boxes and stuff like that, very easy. The reason you would do this is for example in It Takes Two, in 3 or something, in just some level, right? we would have like, oh, here's a checkpoint, and when you reach that checkpoint, play a cutscene. And when you reach this point, then some level event is supposed to happen, like, oh, you walk in here and a door opens and so on. And that's just kind of a pain in the ass to code in actors, because it might only be used one time, like only one time maybe this cutscene will play, like this specific level event will happen. So then it's quite nice to do that inside of the level blueprints. Because then you can reference actors directly. You don't have to worry about like property references and shit like that. You can just open a door, then you can just get the reference to the door and call open on it or something. And I can put multiple trigger boxes for the same door and whatever I want to do. So stuff like level flow, like how does a level play like, is very often coded in the level blueprints. Stuff like enemy spawners, like now if you go into this trigger box, then start spawning wasps or whatever was coded in the level blueprints. And stuff like escape when you're flying the plane. That will be the same thing, like the plane flies into a trigger box and then we teleport the plane here and play a cutscene. Like all of that stuff will be coded in the level blueprint. So the systems are coded in actors, like how the plane moves, how it shoots, and all of that stuff. The bullets, that will be coded in the actors, but then the actual level flow, like what happens in the level, that will be coded in the level blueprints. And they're very good for that. It's very easy to make very nice level flows in this blueprint here. Because you can easily add stuff like, you're playing the game, and then after 10 seconds, then start spawning enemies from a particular spawner or something. Like, it's very easy to control that flow, and it looks very nice. It's quite easy to work with. So when the designers are making the actual level, most likely they will do that in the level blueprints. So you should provide easy to use functions for your enemy spawners, for your if you're gonna have cutscenes for some reason, if you're a cutscene manager, there should be easy functions to call so that they can sort of control what happens. Like, they can call a function just to start spawning enemies and blah blah blah. They should be easy to do that, and then the actual flow of when it happens, that is controlled through the level blueprint, so that they have a proper view of everything in the level. So that's level blueprints. And that's quite nice for our game. Like if the designers want to make a new map that has some cool level mechanic, like I want to have a cool bridge that goes down when a certain player is first or something. When you go to the trigger box, then a bridge should lower. Then it's quite easy for them to just code that in the level blueprint for that one level, like just for just that special level they used in the level blueprints. Add a trigger box, and then hook up to that trigger box to lower the bridge when someone goes through it. So very useful tool, mostly for designers, less for programmers. But you will have to sit in a level blueprint at some point, only if it's to solve bugs.
Do you make like CPPs of these level blueprints, or do you stick to just using like the blueprint that's in Unreal?
Rarely, I would say. Rarely. There was some parts, like in Snow Globe, for example, in Text 2, we made an IndyScript version, like a base class for the level blueprint, which you can do. Like here, you can see in class settings, you can see what the parent class is. So here you can make a level script or a level script actor base class in C++ or in IndyScript or whatever, and then you inherit from that in the blueprint. But that's only really used to do stuff like, okay, if there's something really complicated that needs to be done. I think it was Snow Globe. It was like initialize all of the snow globers, like little dudes running around and stuff like that, and setting up all the puzzles and all of the mini games that had to be called quite often, but it was quite a lot of code. Then we would put that in AngelScript. But of course, the downside with putting stuff in AngelScript or in C++, whenever I say AngelScript, you think C++ really. The problem with putting all of that stuff in C++ is that you lose the thing where you can sort of reference actors directly, because you can't do that in C++. You can only do that in blueprints. And hooking up events to specific actors, you can't do that anymore. So if you did a C++ base class, it will most likely just do core things that is done often, but it's quite complicated. You might put that in the C++. But I would say it's quite rare. Because you don't really gain that much from doing that. Like you could as well just make a custom event here to just set up important stuff. Just call that. And also you lose the nice flowy stuff of the blueprinting system. Like you lose stuff like delay and all of those neat functions that exist in Blueprint. You kind of lose that as well. And especially in level blueprints, that's when these things come into, like, where they really shine. Where they want to do, like, oh, trigger, you press a trigger and then 10 seconds later, enemies start coming behind you or something. Like, you lose that kind of niceness that you have in blueprints to really control the flow. So I would say it's quite rare. But yeah, it's also, of course, I know in A Way Out, we put way too much stuff in the level blueprint, so it's easy to go the other way around, where there are like entire systems written just in the level blueprint, instead of in an actor, and then it becomes quite tricky to debug them and make them kind of work well, because it's in blueprint, and blueprints aren't the best at that sort of thing. So you would open up a blueprint and it's just like this huge thing where it's like the whole level and all these kind of subsystems everywhere is written straight in the level blueprint. So it's it can definitely go a little bit too far as well. So
doesn't it become tricky to modify if you have it like too large?
Yeah, it becomes a problem. So that's why in It Takes Two we kind of shaved down a lot on our use of level blueprint, and instead made like very helpful static functions that you could just call from the level blueprints and then use it that way. So move code from the level blueprint into C++ somewhere else, which is quite nice. But it is a hard line to walk, and it's fine. It is what it is. Oh shit. So yeah, we can do stuff like, I want to have a rotating cube. I'll make it that. So instead of making like a new actor of a cube that rotates, I can just place a cube in here. Remember to make it movable. I'll make it movable, otherwise we're not going to be able to rotate it. Add a cube, make it movable. And then I'll just go into the level blueprint, tick, and then tick I will just reference that actor, so I'll just hold R and click to get the reference. And then just add actor world rotation. I'll do like split this. I want to yaw it, sure. I'll just multiply that by 180. Something like that. So we can do simple small things like that. Just like, I just want to rotate a cube in this level for some reason, and I don't want to make an actor for it. So then, yeah, okay, it's fine to just put that in level blueprint. So now when I play, the cube rotates. So yeah, that's the level blueprint. I couldn't think of a good way to introduce it. I was kind of waiting until we found like a really good use for the level blueprint. it's like, oh, this would be perfect, but then it just never showed up. So I was just like, yeah, let's just go through it. So that's it. When you're working with designers later, I'm sure you will see why they like it. Whoops. Okay, perfect. This brings us into the next bug we have. Can anyone tell me what happened here? I killed the other player, and then we got a crash here. Why?
Is it because that player doesn't have a location anymore because it's gone, and we were trying to like do the average between the different locations?
Yeah, that's a good. Yeah, that's it. Why is this null pointer though?
Is it because we didn't remove it from the list when we destroyed the car?
Yes, we don't remove from the list. So what happens then?
So it points to nothing, right?
Yes. But why is it null pointer and not a garbage pointer?
Because of the U property, right? That's
Yes.
a weak pointer.
Yes, very good. Exactly.
Wait, how did you get it to crash, Eva? You just
Well, it's kind of
shot.
it's kind of random when it crashes, but yeah, I used shoot the other player and then
Okay.
wait. Right now, it
Yes, I-
happened to happen right away, but it's like whenever the garbage collector kind of comes in and collects that car.
Okay.
Yeah. So it might not happen right away, but
Well, that's kind of weird though, because it still kind of acts like the player is there. How does that work?
yeah. So the player still exists. Like it's like kind of, it's not ticking, it's not doing anything, but it's still like the object is still there until the garbage collector comes in and actually like deletes it. So that's why we can still kind of reference it. Even though, like, if we started calling functions and stuff, like if we started doing dangerous stuff other than just like get actor location, then it would eventually like be like, hey, you're trying to do stuff on an actor that's destroyed. Like, what are you doing? Like if we started trying to call like blueprint implementable events and so on. But then of course, as soon as the actual garbage collector comes in, and yeah, there you go. Now the garbage collector came in and he swooped it up. Then it will say like, okay, this actor is destroyed now. This array is referencing it, like that U property array that we made on the game instance. Like it will know that this array is referencing the car. So set that pointer in the array to null pointer. So that's how that works. So that's a pretty nasty bug. So let's fix it. So I'm just gonna say when the car destroys itself, and that is called end play. So end play means you were destroyed for some reason. And we can actually find out the reason if we go to phase 2. Can I do this, please? Nope. Okay, great. Oh god. You go to definition, sure. Okay. So it's defined here. Yeah, there we go. So here we can see end play. And we see that we have this end play reason enum. If I go there. Here we can see that there are a bunch of different reasons why an actor might go might be destroyed, or might end its life. So it might be when it's destroyed, which is what we're doing now. It can also be level transition. So like when we're going from one level to the other, then all of the actors in the old level will be removed. So end play will call on all of them. Yeah, but end pi. Oh, by the way, pi. You will see this a lot when you're at an industry or at a company. Pi means play in editor. I was very confused when I got into Hazelight. They were all saying pi all the time, and I had no idea what it meant. But yeah, it's play in editor, so that's when you just click play. Then we have when you're streamed out. No idea what that means. When the application is being exited, I guess that's when you quit the game. Not sure. Never used it. So we just have to add this e end play reason type. So this is an old style enum where it's wrapped in a namespace. So e end play reason is actually a namespace, and then inside of that it has an enum called type. So remember when I talked there was multiple styles of enums, and this is the old style one. And this was to avoid the enums coming into global namespace. That's the reason why they do this. So we have to do e end play reason : type, and then I'll do reason. Put this in here.
Ryder suggests to make it a const.
Okay. I guess that is the base version, so I guess we'll make it const. Actually, let's look. Yeah, it is const in the parent version, so let's just make it const. No idea why. That seems weird to me, but whatever. So we get a reason in. Reason to live. And so we'll just get the race game instance. And just remove ourselves from the car array. I'll split this up into multiple lines actually. Race game. It's kind of hard to see otherwise. There we go. So we'll just remove ourselves from the list. We'll see ourselves out. Let's make sure to call the super as well.
Wait, we do cars.remove like it's a set.
Like it's a set?
Yeah, you do. Wait, is that a thing? Maybe.
Yeah, that will just remove this. That will just remove this entry from the array. So we'll find where that pointer is, and then remove it.
Oh, okay. I didn't think that existed for this.
That's why I prefer. That's why I really prefer T arrays to std vectors, because they have actually neat readable functions instead of doing like the std : find, and then like you have to provide the iterators and blah blah blah. While in a real, it's just like, oh, I want to find, I want to find an entry. It's just like find. It's just like so much easier. So much easier to
You
use.
need the context on line 27, right?
Ah, very good. Thank you. Provide this. Then we'll include the instance. So just include race game instance.h. Emil, your hoodie is in your teacher's chair. Not really. I have a hard time believing that. Which hoodie? It takes. Oh, is it the It Takes Two one? Oh, they mean the FG. Oh, the FG20 hoodie, right? Oh, sick. Okay, I'll come and get it. So now, hopefully, when I go and die, then there we go. So the camera updated to not follow that other one because he got removed from the list. And then yeah, if no cars are there, then I guess nothing happens. It's kind of weird. This is weird. It should crash here. Why isn't it crashing?
Does it have a safety for dividing by 0
I
by
guess.
default?
Yeah, I mean, I guess. Let's see. Oh, okay, yeah, that's fine. Oh, I had F11. Whoops. Yeah, so here should be 0 divided by 0. What does that become? Oh, okay, it just become none. So I guess the lerp gets us out of there. No, okay, location becomes none. And I'm guessing this fails? I'm just curious now. Yeah, like here you can see like is pending kill is checked here, so you can't move. You can't move anything if the actor is pending kill. And pending kill means it has been destroyed. It has been destroyed, but it hasn't been cleaned up yet. That's what if pending kill means. Yes, it seems like somewhere here it fails. So yeah, okay. So it saved us from nunning. I mean, I'm interested that we didn't crash by divide by 0 though. I guess they maybe handled that somehow. But let's just fix that. So we'll say like if, let's do an ifs here. It's like if num cars equals 0, then just return. So we don't have nans. So we don't get the nan epidemic. Yeah, they decided that 0 divided 0 is like, oh, it's 0. Ending that debate. But cool, sweet, awesome. Fantastic even. So that's level blueprints. So now if I kill this guy, bang, then the car will focus back on me. So maybe now doing something like respawn or something would be quite nice. So let's take a break. Let's take a 10-minute break, and then we'll do something else fun. So I'll see you guys back 14:05.
Perfect.
In which file is the num_cars variable?
Sorry?
In which file is the num_cars variable?
In the race camera.
Okay. Yeah, too many files, so sometimes it's hard to find where you are.
I get you.
Yeah.
McDonald's, how can I help you?
I would like
Please, sir, there's a long queue. Could you hurry up?
do you
You
have
have cake?
salsa?
Hurry it up.
Everyone's talking at the same time. Excuse me, sir. What do you want?
Cake.
We don't have cake.
Oh, do you have smoothie?
No, this smoothie machine is broken. I beat it with I beat it with a hammer.
Uh,
Do you have any cake adjacent foods?
We have is a burger cake adjacent?
Yeah.
Yeah, I
Sounds
want a Happy Meal.
Okay. Do you want a girl or a boy toy? Because we are still in 1955.
Girl, obviously.
Cool, you're dope. The police will be here in 5 minutes to arrest you, so bye-bye. Alright,
do you
roleplay.
have a Whopper?
Roleplay over. Good
Damn
session,
it.
good session, guys. Good improv. Let's do some.
Oh yeah, right. Are you recording?
Yes.
Dope.
So this is on. This is
Can
on,
we see racecar.cpp again, please?
please, for the love of Christ. Here it is.
Mine is complaining in the super call inside end play that the name must be followed by double colon must be class or namespace name. What am I doing wrong?
Show paste. Show me your screen.
Yeah.
Yeah, you didn't. You just wrote M play. You didn't write a race car colon M play.
Right.
There's your problem. No problem. Yeah, baby. Oh, I love you, baby. Okay, so let's do widgets, because I haven't done widgets. And they're quite important. I died. So let's make some Digidarn widgets, dude. Bro. So, dude, I'm so fucking good at this game. Look, I'm gonna hit this shot. I'm gonna hit this fucking amazing shot. Look at this. Fuck! It's fucking trigger, man. Like, I'm gonna hit this fucking sick shot. Look at this. Like, off screen. Look. That was close. So we're gonna do widgets. And I was peeing in the toilet. And I was thinking about which kind of widgets would be good to add to this game. So let's do like I can't think of a game analogy, but let's do something like let me take a screenshot. Let's do something like, you know, we have a corner up here that displays player 1's item, so it'll be like here's a pooper shell. And then over here will be like player 2's item, and then player 3 and so on. So in each corner will be each player's item. So let's do this then. That will be the goal. So how do we add a widget in general? In theory. So first of all, we have to create a widget. So let's do that. So I'll make a new folder in Blueprint. In the Blueprint folder in content here. So in Blueprint, I'll make a new folder. I'll call it widgets. Sure. And to make a widget, we will go to user interface, and then widget blueprints. Usually I call those WBP for widget blueprints, like the prefix, but I mean there's no standard here. I mean there's no standard. So WP, I'll call it test, the test widget. I'll just open it up. Just double click to open it up. Now I'll say widgets are its own monster for how the widget system in Unreal works. I think it's quite good. Like I really like the widget system in Unreal. I think it's better than Unity, although that being said, I haven't worked with Unity all that much. So I mean, I'm not gonna discriminate something I do not know. But we start off with an empty canvas. And we don't need actually to have a canvas as a root, but that's the default. So this will work very similar to how Unity works by default. So in Unity you create like a canvas, and that becomes like the widget root, right? And then everything's drawn, and then you add like buttons and stuff on there. And it works quite similar to that in Unreal in one way, where we get a canvas as a root to our widgets. But it doesn't have to be the roots. Excuse me. We will keep it.
How did you get to this window when you made the widget?
I just double clicked it.
Yeah, I mean, what did you select when you made the widget?
Oh, right clicked and then user interface widget blueprints.
Oh, okay.
Damn, Anders, you wanna be the artist? Looks great. Looks good. So I'll add some text. At least add whatever just as a test. So this in the palette here, we can select from a bunch of widgets that we can add. Circular throbber, that's what they call me. So I'll add text here. Yeah, I'll just drag that out. So now a text widget. I can drag that around anywhere since we're in a canvas right now. So let's add a text, and I'll make it bigger. Let's see, where's size font here? So let's just click the widget, click the text here. Let's go to font. Whoops. Go into font and just fucking spice that shit up. Yeah, make it real big. You can see the actual size of the widgets doesn't matter for text. Like text doesn't care how big the actual text widget is. Like it will just draw wherever it needs to draw. So I'll do size to content here. See that? In the here's a category called slot, canvas panel slots. So I'll just do size to content. So now the actual size of the text widget will be just however big the text inside of it is. We won't deep dive into stuff like slots, or at least not today. I'll just make something. I'll just drag it in here. Yeah, that's fine. It's a great widget. I'll just type something. Let's do hello from me. Yeah. So just click the text, and then here in content text, you can change whatever the default text should be. Make it a bit smaller. There we go. So that's our test widget. Looks very good. So let's add it to the screen then. So let's just do it in a level blueprint. That's a great place to just test stuff around. So I'll just go into the level blueprints. Do begin play. So whenever we start the level, I wanna create widgets. So I just dragged out, typed create widget. So here we select which type of widget we want to make. So there's a few ones. Animation sample UI looks pretty dope. I'll do WBP_test. So that's the widget we just created. So let's select that. So that's the widget that's going to be created. Then we have an owning player. This is for stuff like input. So if you want to have input in your widget, like if it's a main menu thing, for example, then probably you want to be able to take input from the player somehow. And this owning player, that is the player which input will be getting. That is because of course we can add multiple widgets for each player. Maybe each player wants to send in their input. Like you can imagine like a ready screen, for example. Like every player has to click A to mark themselves as ready. Then we will want to take input from each of the players. So then perhaps we would create like one of these ready widgets, one each for each player. So then that widget would you only receive input from that particular player. It's a can of worms. We will leave it for now. I don't think we need to provide a widget or an owning player, so we'll just leave it. And then to actually add it to the screen, because right now we created it, but we haven't actually added it anywhere. So we won't see anything. Like if I start now, like we don't see anything. So to actually add this to the screen, we have to, from the return value, I will do add to viewport. Ta-da! So now we can actually see the widgets. Isn't that just fantastic? Oh mamma mia. So that's cool. Great.
Wait, can you go back real quick?
What does the little TV screen mean?
That means that it will only run locally. So that's for multiplayer stuff. So when you're doing networking, this icon means this will not be called anywhere else. It will only be called locally. I think. That's my understanding of what that means. Why this doesn't show up on other stuff, I'm not quite sure. I think there's this whole there's this whole subsystem with widgets and networking that I just don't know that much about, unfortunately. So that's how we add widgets to the screen. Very nice. Hello from me. So let's start things off casual. We want to add some sort of player status screen. Some sort of player status screen. So let's make that then. I'll make a new one. I could have just done that in the beginning, but whatever. I'll do player status. What do we call it? Player. I'll do it race overlay. Sure, let's just call it that instead. You'll see why in a minute. So we'll have our little race overlay here. And we want to have... So I'll just add an image just as a temporary. Let's see, let's add a texture. So I'll go into appearance, brush here, and then image. Yeah, it looks great. Look at that little guy. So I'll add an image to represent the player for now. So we want to have one image per player, right? So I'll set a good size. Let's do size. Let's do 150 by 150. Pretty good size. So I just went into the image, I clicked it, and then in here I can just set the size. And now I want to work a little bit with anchors. Because of course we want to have one of these boys in every corner. So if we copy this, we want to have them like this in every corner. And this looks fine, right? The problem, of course, is that these positions become quite problematic. You can see it's 1700 in the X direction. Of course, that makes sense because it's 1700 pixels to the right. I don't think it's actually pixels, but let's just say pixels. Of course, that's going to be dependent on resolution and stuff like that. What if we're playing in a different aspect ratio, right? You can see down here that the default resolution and aspect is 1280 by 720, and that's an aspect of 16:9. But of course, like I can change the resolution. Yeah, so here I'm changing the resolution. Like here, for example, yeah. Now we can see we're in 1610 aspect. And then you see that these guys are dropping off the side of the screen. So this clearly doesn't work, where we're kind of just hard coding in a position like this. It doesn't work. So instead, can I go back to just like the defaults? I don't remember what the default was. It doesn't matter. So instead what I'm going to do is I'm going to set its anchor to be the top right corner. So now its position isn't based from the top left corner, like it's a default, like for this guy and for all the other guys. Its position is sort of based from this corner. Instead, I'm going to say your position is going to be based from the top right corner of the screen. And so now you can see it actually has a negative X position. It has negative 200. And that's because it's offset negative 200 from this side of the screen. So that's great. So now we can sort of position this. And now we can actually just copy this. We can sort of say like, oh, this is supposed to be 80 pixels. 80 pixels in each direction from the quarter. So we can say that. Okay, so each of these status icons should be 80 pixels down and 80 pixels right or left from the side of the screen. So we can do the same here. So let's do 80. Yeah, it will be negative 80 in this case, and then 80.
How did you set the image? Because the image button doesn't show up for me.
You have to extend brush.
Oh, okay.
But we have a problem, right? Where if I type -80 here in the position, even though I have the anchor on the top right, the position of the widget is actually the top left part of the widget. So you can see like, okay, while the top left part is placed correctly, the rest of the widgets happens to be off screen. So I have to do like, -80 minus, you know, whatever the size of the widget is, -150. Okay, so -230. Still a little bit hard codey, because if this changes size, then suddenly it's not in the right position anymore. So what I'm gonna do is here we have alignment. And different from anchors, it's quite similar, but different from anchors, alignment means which part of the widget will actually be aligned by, you know, -80, 80. Like you can kind of see that as the anchor on the widget, which part of the widget will be positioned at -80, 80. And right now we have 0, 0, which will be the top left corner of the like this inner widget here. But if I change this to be 1 instead, then you can see now it looks similar to the top left image here. And that's because now, sure, we still have the same position, -80, 80. But instead of that being the position of the top left corner of the image, since we have alignment of 1, that means the top right corner of the image will be positioned at -80, 80. So there's kind of two anchors that you're working with. You're working with like where is the position relative to, and then you have where on the sub widgets, I'll call it sub widgets, will that position actually represent? Will it be the top left corner of the widget, or the, you know, if we want to have it the middle of the widget, we can do 0.5, 0.5. So now the middle of the widget will be positioned at minus 80, 80. Relative to our, you know, our anchor here. So you know what, maybe that's even better. Maybe I'll do use 0.5 for all of them. So then we don't actually have to change the alignment for each of these widgets. Actually, no, fuck that. No, we're not going to do that. Because then again, if we change the size, then the distance from the edge of the screen is going to change. So now you can see if I change the size, so if I set the size to be 500, the top right corner is still in the same place. So it's still the same distance from the edge of the screen, no matter how big the widget actually is. Quite nice. So then I'll do the same treatment for all of the other ones. So here, this bottom left one is going to be anchor bottom left. And then the position is going to be 80, and then minus 80 in the Y position this time. So we're going to move it up from the anchor. And then I'll set the alignment to be 0, and then in this case we want the bottom left corner of the image here to be the sort of the alignment. So I'll do 0, 1 for the alignment. So that means the bottom left side of the image will be at position 80, minus 80. I'll do the same for this guy. Anchor will be bottom right. Position, it will be minus 80, minus 80 in this case. And then the alignment will be 1, 1. So I mean, it's okay if this doesn't, if this seems quite complicated. As I said, widgets are its own ecosystem. Like there's a reason why there are UI programmers, like dedicated UI programmers, because it is quite a thing to work with widgets. You really have to sort of understand what does the system do, what tools do I have, how do I use them to make like widgets that are easy to work with. Because I mean, the problem that always happens in every student project is that you don't use anchors, you don't use alignments, you just kind of drag stuff on the screen until it looks right. And then inevitably someone's gonna select a different resolution and suddenly half the screen is off screen. Like half the menu is just cut off because the resolution wasn't what they had in the editor. And because I didn't work with anchors, suddenly it's unusable because I selected a different resolution.
How do you handle like UI scaling and that sort of stuff when you have like different resolutions for games? I mean, if you have like an image, what kind of image do you need?
Yeah, so Unreal does that for you. In this case, in Unreal, you don't have to worry about that stuff. So even if you select a huge resolution, let's say I'm playing on a 4K monitor, right, and I select 4K resolution, then the UI system will kind of keep it to look about the same. Like the ratio obviously can change, but the look of it will be slightly the same. So these images should keep roughly the same size, even if you're playing on a huge resolution or a small resolution. And that's why these numbers here, minus 80, that's not pixels. Like this minus 80 isn't really pixels. It's kind of a rough approximation of what a pixel is. But in the end, that could be 10 pixels if you're playing on a really, really small resolution, or it might be like 1,000 pixels if you're playing in 4K. So we'll scale the widgets to look roughly the same no matter the resolution. The only thing you have to worry about is aspect ratio. You can even see that down here, the DPI scale. You can even see here what the current scale is.
Good. I don't have to worry about that stuff.
Yes, that's a can of
if I
worms.
work with this.
That's a huge can of worms. It can come to bite you in the butt though, when you're doing like screen to like world to screen projection. It can kind of come and bite you in the ass that you also have to take DPI scale into account. So it's a bit of a double-edged sword there. But all right, so now we have our race overlay widgets. Looks amazing. So now let's add it then. So I'll go into class and I'll do add the race overlay here. So we switch this class out in the level blueprint. So instead of spawning the test, we spawn the race overlay. So now if I play the game, there we go. It should look good. And if I do stuff like switch the screen in, just changing the aspect ratio here, which you see that it still looks okay no matter what the aspect is. Like, of course, like it's fine if it looks bad when you have this aspect ratio. I mean, that's fine. It should handle it, but it's okay if it doesn't look good. But as long as it handles it, that's all I care about. And I do this a lot actually when I'm making UI, especially when I'm making like editor UI, when I'm making tools. I always try to do this a lot just to make sure that it works. Like if someone wants to work on a long, like a vertical monitor, for example, I want to make sure that the UI is usable even if it's a vertical monitor. So I tend to do this a lot just to make sure that my UI kind of works. Great. Okay. So, of course, though, we don't want to spawn the UI from like from the level blueprint. That's kind of lame. Like, you know, if we make a new level, suddenly we don't have the overlay anymore. That's kind of sucky. So we have to kind of find a good place to actually place our UI. Like where it should be spawned. And I'm kind of thinking where the best place would be. Probably the best place would be the HUD class. Now, I'm not an expert on the HUD class, I'm afraid. And I remember that Sahil actually talked a little bit about the HUD. And they said like, yeah, if you want to do... Why did I die there? Oh yeah, I went to the trigger. Sahil kind of talked a little bit about the HUD. And he said like, yeah, you should use this for all interface stuff. That being said, I've never used it. So it definitely isn't needed. Like you don't need to make a HUD. Like you can add widgets just fine without a HUD. But I'm guessing the HUD is kind of useful for that. But I'm not gonna do it because I don't care. So we're gonna do it in game mode instead. Fuck it. We do have a game mode, so I will actually do that stuff there. All we did in our game mode was just override what the default pawn was. But this could be a good place to also add some widgets. So what we're gonna do is that I'm just gonna override begin play in race game mode. There we go. Gonna call it super. That's very important for game modes. Game modes do so much shit in begin play that's super important, so we have to remember to call begin play or super begin play in the game mode. Otherwise, our whole game is gonna just go tits up in the air. I'm trying to remember. Whatever. Doesn't strictly matter. You can use HUD. You can use the HUD class if you feel like you wanna try that out. So the reason I was thinking is that like I would want to do this in a game instance. However, it makes sense that since the game instance lives forever, it's not a great place to do it in because like we don't want to have the overlay when we're in the menu, for example. So it does actually kind of make sense to do it in the game mode. Okay, so in begin play we want to spawn it then, but how do we reference it? We don't have a reference to it, so we have to make a U property. Again, if we want to reference anything blueprints, we have to make U properties. So I'll make a U property. I'll make it edit default only. I'll make a category. I'll call it the interface. Maybe widgets. Yeah, let's do widgets. So I'll make a T sub class off, and then I'll do U user widgets. I call it overlay widgets class. Okay. So now we have our overlay class. So how do we add it then? Well, we actually just do, if I remember correctly, we actually just do new object here. So we'll use the version that has a class here. We'll use this one. So here, new object T. So we provide an outer, and then we provide a class. So this is the same thing we did for the, if you remember, in the pickup. If I just go there, look at it real quick. There. Yeah, remember in the pickup where we newed the U raise power up? So we're gonna do the same thing, but instead of spawning a U raise power up object, we're gonna spawn this widget. So we're gonna do the same thing. So we're gonna do a new object. The outer will be this. Doesn't strictly matter what the outer is, but we'll provide this. And then the overlay with class is gonna be the particular class of object we're gonna spawn. And I want the return value as a user widget, so I'll just provide that as the template. And then we should be golden. So I'll just do widgets, or I'll call it overlay. So we'll new it, and then we'll do... Right. Where was that function in C++? I don't quite remember. I didn't usually do this. Let's see. Can I... Oh, it is just a... Oh, it is just a function on the user widget. Okay, never mind. So we'll just do overlay.
Is there a reason you made the auto a pointer like that?
Yeah, so the thing with auto...
Doesn't it become like a double pointer now?
So the thing with auto is that it will try to figure out if it should be a pointer or not. So if I just do auto like this, it should work. Like if I just run. Oh, whoops, we not have a U user widget defined. So I'm just gonna forward declare it here, class U user widget. And then in the CPP file, let's see, where does it live? User widgets. Runtime UNG public blueprint. Okay, so in blueprint then. Since I'm going after public here, so public, remember that was the folder I was looking for. So after public we have blueprints. Okay, so blueprint slash user widget is gonna be the winner. So includes blueprint user widgets. So if I run this, I think it will compile. If it ever wants to. Yep. Oh. Oh, something went horribly wrong. Unresolved external symbol. Uh-oh. Uh-oh. So this is a big... so when this happens... I didn't think we would need to go through this now, but okay, I guess we have to. So the thing with Unreal is that they have something called modules. It's not C++ modules. You might have heard modules as when people are talking about the C++ standard and whatnot. Unreal doesn't use that. Instead, they have their own internal build system. That's why we have to look for the public paths and stuff like that. That's because they have their own build system, and it works with modules. And this user widget class is in a module called UMG, which stands for something. It's Unreal, my God, or something. I don't know. It's something. UMG is the blueprint widget system. So when we were making user widgets in Blueprint, we were using the UMG system, which is their blueprint widget system. And the thing that's the problem here is that when we are making our game code, that is also in a module. So we have our race FG_racing game module, and to use UMG, we have to tell the build system, hey, in my race game, we are using this UMG module, so link us with the UMG module. And we're not doing that right now. So what we have to do is that we have to head into this FG... Is it that one? Yeah, it's this one. We have to head into this fgracing_game.build.cs. So that's gonna be in your folder. It's gonna probably under this or whatever your project name is. Under this folder that's named after your project name. I'm just gonna minimize these. You should find this fgracing_game.build.cs. And this is the thing that controls the build system, the Unreal build system. It's written in C#, so all of the build files that's going to describe how a module should be built are written in C#. So here's sort of the thing that defines our module and how our module should be built. And here we can see public dependency module names. And that's the other modules that we want to depend on. You can see there's a bunch of them already added. Hold on, I'm gonna format this a little bit better. You can see that there's a bunch of modules that we're already depending on, and that's why we can use stuff like actor and UObject and all of that stuff. The reason we can use those at all is because we have those modules already sort of dependent on. So core and core UObject will be stuff like UObject, and here will probably be like arrays and stuff. And then engine defines stuff like actor and game mode and all of those stuff that we're using. Input core is doing stuff like input component and blah 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 and so on. It's a bunch of shit. So all of that code is split into its own module. And we want to add now, so okay, in addition to core U object engine, blah, 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 all of that stuff, we also want to use UMG, because right now we're doing widgets in code. So I'm just gonna add here UMG. So that will mean like when we're building our code module, it will know like, okay, you're depending on UMG, so that means I should link you with the UMG module. And there's a bunch of, I mean, there's so many modules. There's like AI, modules for AI stuff, modules for sound stuff, modules for animation probably, and, you know, to actually use those in code, you have to remember to add those to the public dependency module names here. So that you can actually use all of that in code. It's a whole can of worms. I didn't think we would actually have to go in here. I thought UMG was included by default, but I guess it wasn't. And here I can even say like, oh, if you want to use Slate UI, which is the, remember what I said is that's the core UI system that UMG kind of compiles down to. You have to uncomment this line to actually get Slate and Slate Core. And it says like, oh, if you want to do online stuff, so if you want to do Steam or Epic Game Store or something, you have to uncomment this line to get access to that module. And so on. And you can do a bunch of other shit in here if you want to. It's module rules is quite nice. But it is a can of worms. So, right.
Is there like how would you find out more about this? Or is it like overkill for us at this point, like to actually look at it even? Or
we can search and see. Let's see, build CS Unreal. So here they have some documentation from their Unreal build tool. So here we can probably go to modules. And yeah, so here's they see like, oh, here's the base module and what it looks like. So here's a bunch of shit, like a bunch of properties that you can set for your module. So yeah, if you want to add like precompile, I have no idea what that does. Use precompile if you want to do a precompile header and blah blah blah. Legal to distribute object code. That seems a bit scary, but alright. So there's a bunch of stuff, but usually you don't go in here. Like, I mean, when you're making a game, usually you're building the game in C++, right? The only reason we really go in here is if we want to add a module, like we want to depend on another module, or if we, I don't know, if we want to set something up to make the building a little bit nicer. But that's something that's one build engineer goes in, does once, and then it's never touched again. So it's not strictly needed to know. The only thing you need to know is that if you're trying to use a system or a module that you haven't depended on, so essentially if you get super scary, if you get these super scary messages saying like, oh, unresolved external symbol for stuff that you didn't write, like, so here I get like, for you user widget static class. That's how I knew this was a module problem and not that we like forgot to define a function or something. Is I knew that, okay, we didn't make this class and it's saying unresolved external symbol. That means, okay, that's in a module that I have to use. So that's the only reason.
Tell which module you have to use, like, because we had the widgets and we had to use UMG. How did you make that correlation? Did you just know that, or was there something in the error that told you that?
Yeah, a little bird came and whispered it to me. No, yeah, so I happen to know that that's UMG, but I could easily figure that out by just checking the path. So if I hover over here, you can see it says like source / runtime / and then it says UMG. Then I knew, okay, this was the UMG module. That's how I knew that. So you can actually go and look at, like if I go, like here are all the modules that you can add. So here's like Linux, if you want to do Linux stuff, or iOS, and foliage, eye tracker. Like there's CUDA even. Oh, that's cool. So there's so many different modules that you can include for different reasons. So yeah, they're all in here. So that's how you figure out which module it is, just by the name of this folder. And if you're unsure, you can just ask. Cool. So now we're depending on a UMG. So now hopefully, unless I did something else wrong, then we should be good. So you can even see it says like in. Oh, yeah, it did work. So you can see here in output. Oh crap! It went away. Oh god, why is it over there? Docket. Okay, the docket. Pin. There we go. Finally. Okay. So we can see in the output. No, show output from build. There we go. You can see in the build output here. It says like invalidating makefile for FG racing game editor. FG racing game.build.cs modified. So it's detecting like, oh, you changed the CS file. That means like, okay, I have to update the build system to actually do what you wrote in the build file. So that's quite nice. So I mean, I quite like the Unreal's build system. I think it's quite easy to work with. Like it has its quirks. Like it's definitely the sort of thing where you kind of have to know what you're doing to use it. But once you know what you're doing, it's quite good. I think it's very easy to add new modules and make them include each other, and it's very nice. I like it, but not something I think you guys should really dig into unless you really, really, really want to.
A question about those modules as well. Like, would a sort of big company make their own modules to include? And that's sort of a library of functions or something? Or am I out skating?
I think we did for at Hazelight. I think that our online module, so we did our own networking, right? So we put all of the networking code in its own module. And I don't remember why, but we did. But we didn't have that many modules now. We had like one editor, that's the usual one, and actually we can see that it already has kind of made a module for us that is just editor. Here. This is a target, which is different from the build, but it's essentially the same. So we have an editor module kind of made. It doesn't have any code or any build info, so it doesn't actually build. But it has made one for us. And that is for making editor-specific stuff. So if you want to do some tools, like, okay, this is going to be a tool in the editor for doing something, then you put that in the editor module. So we had that for Hazelight. We had like a Haze editor module where it did stuff. But I would say like it's not very common to add more modules than that, because usually it's like you're making a game and pretty much everything in the game has to know about each other. So it's kind of like that. All right, new object call with a null pointer class object. What went wrong?
Is the overlay widget class not assigned?
Yes. Overlay widget class is not assigned to anything. So we made the T subclass off, but of course we have to actually go and set it to something. Because right now it's not set to anything. So we're essentially saying like, create a new object with no class. And it's just complaining, saying like, hey, you can't do that. I need a class to be able to make an object. So what do we have to do? We have done this many times now. What do we need? What do we need to do?
blueprint.
Yes. And more specifically,
Widget blueprint.
well, we already have a widget blueprint, but how do we?
I mean, from the class widget class blueprint.
The widget class blueprint.
Yeah, the one we did.
Yeah, yeah, we have to set that, right? Because we have our widget here. We just need to get that into this U property somehow.
But didn't we do some other kind of blueprint from the classes we did with the power-ups? They had like circles instead of some other icon.
Yeah, so we did do that, right, for a few of the things, like for.
Yeah, blueprint class. It says. Oh, it says that on everyone.
Power up here. Yeah, we overridden. We made like a power up blueprint here, right? And that was for the same reason, because we wanted to set a subclass. So we had a T subclass off in the shell power up base class in C++, but to actually set that subclass, we had to make a blueprint version to be able to set that subclass to something.
So do we have to make a blueprint version of the widget?
Well, close, not the widget, but we do have to make a blueprint version of the game mode. So I'm gonna search race game mode, and there it is, race game mode. And I'm gonna make a blueprint version of that. I'll call it race game mode. It's not really, you don't usually take the prefix into the name in blueprints, but I'll do that just because BP game mode is quite ambiguous. So we have to make a BP version of the game mode. Because remember, it's the game mode that had the T subclass of the widgets. Because we're, remember what I said, I'm deciding to add the overlay in the game mode. Like, so the game mode adds the overlay to the screen. So that's where we have the T subclass off, and that's why I have to make a blueprint version of the game mode to be able to set that T subclass off.
I forgot it was in the game mode.
Yeah, it's fine.
That's
we went on like a 30-minute tangent about modules, so I understand that it kind of got lost in the weeds. So now that we're in the race game mode, in the BP version, I can go to class defaults, and here we have our property, our widgets property. So now I can go in and set this to race overlay. Bada bing, bada boom.
I gotta run. Thanks for today.
Yeah, thank you. Yeah,
Bye.
it's actually it's 3:00. Let's end it today.
So, are we gonna have a lesson tomorrow with you?
Yeah, let's do a lesson tomorrow.
Hell yeah.
Hell yeah. I posted in the Discord as well. But yeah, let's do a lesson tomorrow. So we can make sure to get through as much as possible before you guys run into your game projects.
Yeah, good stuff.
Yeah, cool. So let's do a lesson tomorrow. Otherwise, great job today, guys. Did some hard things today. So I'll see you guys tomorrow then. Have a nice evening.
Thank you. Goodbye.
Thank you. Bye-bye.